All right, this is experiment 7, types of reactions and conservation of mass. So let me just go over a couple things. Maybe it'll help you. All right, first, we're going to talk about molecules. Okay, and I know you know all this, and they're just a combination of atoms, combo of atoms. We'll do more of this when we get to chemistry. Okay, so let me talk about so we can balance equations later. We'll talk about the structure. Okay, so for example, if I write CO2, don't worry about naming things right now. We'll name things later. We'll learn how to name them. But I'm sure you all know that this is carbon. Is the carbon, the C, and it's dioxide. Okay, and you see the di means two, and there's the two for oxygen, okay? So this has one carbon atom, and it has two oxygen atoms. Okay, that's clear. Now, if we put a prefix in front, for example, if I make 6 CO2, that means there's 6 of these molecules, these carbon dioxide molecules. And so 6 of these means we have 6 carbon atoms, and we have 6 times 2 is 12 oxygen atoms, okay? Pretty simple. Let me draw another molecule, a little more complicated, and show you something, okay? Once again, don't worry about naming these things, okay? So I'm going to draw aluminum sulfate, okay? This is going to be this Al, there's my aluminum. There's going to be 2 of those, and sulfate, we'll learn this later, SO4, and there's 3 of these, okay? So this is called aluminum sulfate. Once again, we don't have to worry at this stage about naming things. Aluminum, I'm good, okay. Aluminum sulfate, excuse me. I was doing the sulfate part already. Uh, okay, so let's look at what this thing has, okay? So it clearly, one molecule of this, right? This is one single molecule. This is a big, complicated molecule, okay? It has 2 aluminums. You see the two aluminums. Atoms, okay? Now, pay attention to this parenthesis, because that parenthesis means we have 3 of these things in parentheses. Okay, so that means there's 3 sulfur atoms, 3 sulfur atoms. And now you see 3 times 4 makes 12 oxygen atoms. Okay, so one molecule of aluminum sulfate, this is one molecule, contains 2 aluminum atoms, 3 sulfur atoms, and 12 oxygen atoms. Okay. Now, again, suppose I put a coefficient in front of this. I'll put a 4. It doesn't matter. Suppose I have 4 Al2 SO4 3. Okay, so now we have to count again. So this is 4 of these molecules, right? There's 4 aluminum sulfate molecules, okay? So now we have 4 times 2 makes 8 aluminum atoms. I'm just going to write Al atoms. Now remember, one molecule had 3 sulfur atoms, but now we've got 3 times 4 and that makes 12 sulfur atoms. Once again, one molecule has 3 sulfur atoms. So 4 of these molecules has 4 times 3 is 12 sulfur atoms. And one molecule of aluminum sulfate has 12, 3 times 4, 12 oxygens. But now we've got to multiply by 4 times 12. 4 times 12 is 48 oxygen O atoms. Okay? So understand this kind of notation that we'll come back to it. Once again, when we cover chemistry, we'll be doing lots and lots and lots of this stuff. All right. So now we're going to talk about types of reactions that are involved in the lab. Okay. So let's go. Types of reactions. And later when I do some specific reactions, you'll see what I'm talking about. Types of reactions. Types of reactions. Okay. All right. The first one, excuse me. The first one is called combination. And it's just as it sounds. You combine things, combination reaction. And it's also called synthesis because you're synthesizing, you're making something, synthesis, okay? So it's a synthesis reaction. And this is where you take some atom or molecule or something and you combine it with another. And they combine to make AB. Okay? This is called the synthesis reaction. Okay? I'll do this second. The second we can talk about is the opposite of synthesis or combination. This is called decomposition. A decomposition reaction. And again, this is the opposite or the backwards, or put the arrow the other way for a combination reaction. So here's where you have a molecule AB, and it decomposes into A plus B. So you see it's the first reaction, combination reaction, with the arrow going the opposite direction, okay? Simple. Next, we talk about a single replacement. Okay? This is where you have a molecule and it wants to replace one of its constituents with another constituent, single replacement. So this is like a couple being replaced, one of the people in a couple being replaced by someone else. Single replacement. So here, A, as some handsome guy, and here's a couple, B, C, and C says, wow, A is really handsome. I like A better than B. And what happens is B gets replaced by A. Okay? So B is replaced by A, single replacement. Well, we could have 2 couples that swap their mates, and this is called a double replacement. Okay. And I think you can already guess what this is going to be. So a double placement reaction is where you have a couple AB. Okay. A is always going to be the positive ion, B will be the negative ion, but we'll learn that later. And then we have another couple, CD. And again, they're going to swap mates. So A is going to go with D, and C is going to go with B. Okay, so you swap 2 things. That's called a double replacement. Okay, the next thing quickly is called combustion. Okay, combustion is also called oxidation because you're adding oxygen, combustion. So here's a combustion reaction. We'll just take something and we're going to add oxygen to it. Okay, and the end products, and this is important, the end products are always carbon dioxide. I'll write that out again. This is what we saw in the beginning, carbon dioxide. And we get water, H2O, water. Okay, now I'm going to put a little star next to this because for the TEAS exam, the nursing exam, you really should kind of know this reaction, that the end products of combustion, and write this down, the end products of combustion are always carbon dioxide, and you always get water. So whenever you see carbon dioxide and water coming out and we're adding oxygen, this is combustion, okay? So the T's will ask something like this, the end products of combustion, okay? And we'll talk about two types of reactions, okay? Exothermic reaction. Now, the word exo, it looks like the word exit. Exit is when you go out of something, right? When you exit something. So that X looks like exo. This is when heat is given off, or heat, I'll put heat out. Out means given off. So when there's a reaction, it gives off heat. That's called exothermic. Okay. Well, some reactions don't want to go. You have to add heat to keep them going. So for example, when you boil water, as you're boiling the water, if you turn the flame off, then the bubbles stop. The reaction stops. So you're adding heat to keep the reaction going. That's called endothermic reaction. Endothermic reaction. Okay, and that's where you get heat in. Heat, I'll put input. Okay, so you need to put in heat to keep the reaction going. Okay, so those are two quick definitions. All right. Now, what I'd like to talk about before we actually talk about the experiment is I want to say a few words about, and again, we will do this in more detail when we get to chemistry, but be aware you can get a simple one of these problems that I'm going to show you on your quiz. And this is balancing chemical equations, balancing chemical equations, balancing chemical equations. And I'm go through this for a couple minutes and show you the idea. It's not hard. Once again, I look at it as a puzzle. It really is like a math puzzle. And those parents out there, you can do these with your kids where they can learn math and learn how to balance things. It's kind of fun. Balancing chemical equations. Okay. And the essence, what this really involves, okay, is the number of atoms, not molecules, atoms that you put in to whatever reaction has to equal the number of atoms that come out of a reaction. Okay, so if you have 12 carbon atoms going in, you must have 12 carbon atoms coming out. They can be in different molecules, but the number of atoms has to be the same. If you have 6 nitrogen atoms going in, you must have 6 nitrogen atoms going out. even if they're in different molecules, or do a single or double replacement or whatever. Okay, so that's the basic idea. So let's look at a couple simple ones. And this is, as we get into chemistry, you'll certainly be getting this on your exam, third exam. Okay, so I'm going to draw a blank here, Na, that's sodium, natrium, okay? And we're going to add it some oxygen, okay? And the products, okay, are going to be Na2O. Okay, so now let's look. So I'm leaving these blanks because the blanks are going to tell us how many. You see right here, we have a single nitrogen. Here we've got two nitrogens, right? So if I put a 2 here, now I've got two nitrogens, and now I've got two nitrogens, right? Here we have two oxygens, but here we only have one oxygen. So if I put a 1 here, that's two oxygens. And if I put a 2 here, well, now I've got two oxygens. Oh, that's good. Oh, no. Look, now I have 2 times 2 is 4 sodiums. Now I have 4 sodiums on this side, but I have 2 sodiums on the left side. So now we say, oh, no, this can't be. But if I make this a 4, now I've got 4 nitrogens, 2 oxygens. I've got 4 nitrogens, sodiums. I keep saying nitrogens. I'm so sorry. And 2 oxygens, right? So 4 sodiums, 2 oxygens. 4 sodiums, 2 oxygens. So now we say this is balanced. Okay, you see what I mean? It's a little game. It's like a puzzle. Okay, so we'll do a couple of these. Okey doke. And hopefully you'll catch on by the time and if we look at this, excuse me, if we see we're adding sodium and oxygen, this is a combination reaction. I'll just put combo or synthesis, combo reaction, right? You're adding A plus B, you get C. So you get AB. So sodium and oxygen, and you get Na2O. Okay, so it's a combination reaction. So let's look at another one. Now I'll do nitrogen, N2, a nitrogen molecule actually. Okay, and we'll add it with an hydrogen molecule. And on the right side, the products, we're going to get NH3. Okay. Now, I kind of like these ones because they're pretty easy. You say, oh, yeah, everything's easy. No, not everything. But here's what I do. And again, you do it any way that works for you. And I really do recommend Khan Academy, right? Khan Academy for chemical balancing. Okay. Watch their 10-minute video, and they're smarter than me, CAD. Let me. Okay, watch the Khan Academy videos on this, and I think it'll help. Okay, but here's what I do. I see 3 hydrogens there. I see 2 hydrogens there. I think of something like the least common denominator. Like, what can I get them to combine? And the answer is 6, right? 2 and 3. So if I put a 3 here, now I have 3 times 2 is 6 hydrogens. If I put a 2 here, now I have 6 hydrogens. So the hydrogen's balanced. Here I have 2 nitrogens now, and here I have 2 nitrogens. So this is good. So I only need a 1. So the coefficients, if we had this on the test, would be 1, 3, 2. And that balances the equation. In the first one, we would have 4, 1, 2. Those are the coefficients that balance the equation. Okay, 4, 1, 2. Okay, let's go do a couple more. And I hope this helps a little, that you kind of get the idea. Okay, so let's take some rubidium, Rb. Okay, and we'll add it to some phosphorus, P. And on the right, the products, we get rubidium, 3 rubidiums, Rb3, and 1 phosphorus. Okay, so again, the first thing I see is, again, you could do it your way. I see 3 rubidiums here, and I see there's only one. So if I put a 3 here, now rubidium, there's 3 rubidiums and 3 rubidiums. Here, if I put a 1, I have 1 phosphorus, and if I put a 1, we have 1 phosphorus, 3. So this looks like it's balanced. So my coefficients of the balanced equation would be 3, 1, 1. Again, this is a combination reaction, combo, as is this one. This is also a combination reaction. Not all reactions are combination reactions, but these are just what I'm using, simple ones to learn, to get the idea about balancing equations, okay? Let's do sodium. Okay, there's some sodium. And here's a chlorine molecule. And we'll get some table salt, NaCl. Again, this is a simple balancing. Okay, again, we see it's going to be a combination. I think you see it's going to be a combination reaction, combo, or synthesis. Okay, well, let's see. I have 2 chlorines. So if I put a 2 here, now I have 2 chlorines. So chlorine's happy. But now you see we have 2 sodium, sorry. Right? So if I put a 2 here, now I have 2 sodiums. If I put 1 here, we have 2 chlorines. So the coefficients looks like 2, 1, 2. See? Not bad, not bad at all. Okay, let's get a little more advanced, okay? Let's do rubidium and sulfur, okay? Rb plus this sulfur molecule, S8. That means there's 8 sulfurs there, right? Don't forget. And this is going to form, oops, I did that already. I did the line. Okay, excuse me. This is going to form the molecule rubidium sulfide. Rb2s. Okay. Well, again, my first guess, let's balance the S's, sulfur. You see there's 8 sulfurs here, and there's 1 sulfur here. So if I put an 8 there, now I have 8 sulfurs there. And if I put a 1 there, we have 8 sulfurs. So sulfur looks good. But now we've got 8 times 2 is 16 rubidium. So if I put a 16 here, now that works. Okay, so the coefficients on this one would be 16, 1, and 8. And again, this is a combination reaction. Okay, well, let's do something that is not a combination. Okay, let's do something a little different. We'll do 1 or 2 more. All right, we'll take some methane, CH4. Again, don't worry about naming these things now. That's fine. You'll learn this soon enough. And some oxygen. Okay, and out, we're going to get some carbon dioxide. And we're going to get some water. Okay, well, this is a combustion reaction, Okay, you see we're adding oxygen, so it's like an oxidation. There's our carbon dioxide, and there's water. So whenever the end products, you see carbon dioxide and water, you know it's going to be a combustion reaction. Okay. Well, let's see. My first guess, it doesn't mean it's right. Sometimes you take a guess and you try it and you play around, okay? So here I see 4 hydrogens. Here I see 2 hydrogens. So to make them balance, if I put a 2 here, now I've got 2 hydrogens, and times 2 is 4. So the hydrogen looks good. I have 1 carbon there, and there's a 1 carbon there. But look, I have how many oxygens? Wow. I've got, here I've got two oxygens. Here I've got two oxygens. So that's four oxygens, right? If I put a one there, then I have one carbon, one carbon. But now I've got two oxygens, and two times that is two oxygens, so that's four oxygens. So if I put a two here, now I have four oxygens, and I put a one. I think that works. 1, 2, 1, 2. I believe that works. So the coefficients would be 1, 2, 1, 2. There you go. Okay, and we'll do one more. Okay, and we'll take lithium and aluminum chloride. So here's lithium, Li, plus aluminum chloride is AlCl3. Notice there's one aluminum and three chlorines in that molecule, and the products are LiCl, lithium chloride, plus the aluminum. Okay, so if we look carefully, you'll notice, right, that the lithium is replacing the aluminum to match with the chlorine. So this is a single replacement. Single replacement reaction. Okay. This is not easy. Um, but the first thing I'll try, all right, again, I'm just trying. I see three chlorines here. So if I put a 3 here, now I have 3 chlorines. So that's good. Now chlorine is matched. But you see, now I have 3 lithiums, right? So if I put a 3 here, now lithium's good. So I have 3 lithiums, 3 chlorines, 3 lithiums, 3 chlorines, okay? And what about aluminum? Well, we only have one aluminum, so all I need is a 1 there and a 1 there. And it looks like it's balanced. So 3, 1, 3, 1. I believe those coefficients balance this equation, okay? So hopefully you can watch Khan Academy or go over some of what I just did, and you'll have an idea of how to balance these things, okay? So simple balancing, you should be able to count the number of atoms on each side, okay? I hope that helps a little, all right? All right. So now we're going to talk about the experiment, okay? So let's talk about the experiment. Let's talk about the experiment and what you need about the experiment. And I'm telling you now, you should know the names of these molecules. You know, if I give a quiz and you have an experiment and you have certain molecules you're using, or certain compounds you're using, and I ask on the quiz, what were the compounds, and you don't know them, well, that's just ridiculous. That you'd be surprised that I ask what the names of the elements are or compounds that you're using. Okay. First of all, here's what we're going to start with, our supplies. Okay. First, we're going to have 2 vials. Okay, these are 2, and they're plastic, little 2 plastic vials. They're very small. They're like 10 milliliter things. So you have these 2 vials, plastic like that. Okay, and then we've got a graduated cylinder because we want to measure things. Graduated means it's measured cylinder. Okay, so that's going to look something like this. Okay, and there's markings on it. Okay, and we're going to have a flask that we'll put everything in. Okay, and the flask looks something like this, and don't make fun of my artwork, okay? I'm doing the best I can, okay? Those are our supplies, simple. And of course, we need the analytic balance. Okay? And we're going to measure things, I think, to a thousandth or 10,000th of a gram, right? So we're going to measure things to 0.0001 grams, all right? So that's tens, hundreds, thousands. This is the 10,000th of a gram. Okay, so the analytic balance is very, very accurate. We want to keep all these decimal places. Okay, and then the chemicals we're using. Okay, um, first we're going to have sodium carbonate. Sodium carbonate, and that's Na. That's sodium, and there's two of those. And CO3 is carbonate. So there's the sodium and there's the carbonate. Okay, sodium carbonate is going to be one chemical. Okay, and we've got calcium chloride, calcium chloride, and that is Ca. There's your calcium, and your chlor. Oops, that's an A. Okay, and your chloride is chlorine. There it is, and there's two of those. Okay, calcium chloride, and then also we've got sulfuric acid, and all these things are going to be AQ. AQ, I'll write it here, AQ, just so we know. AQ means aqueous. So it's in a water solution, aqueous. So it's a water solution. This compound is in water, okay? So I try to be careful with the aqueous, okay? And then we've got sulfuric acid. And that is H2SO4. And again, that's an aqueous solution, okay? Excuse me. Right? Those are our compounds. Okay? And here's the procedure. Procedure. And the whole idea of this experiment is for you to read and do the experiment yourself, figure things out, okay? We're going to take 10 milliliters of sodium carbonate, okay? And this is going to measure this, measure in the graduated cylinder. Okay, so we're going to measure out. Sorry, my silly picture. Okay, and we're going to measure out 10 milliliters of this stuff. Okay, and then we're going to take that and put it in, put into the vial. Put into the little plastic vial. Okay, so now we have that. And then we're going to repeat this same thing. Repeat for the calcium chloride, for CaCl2. So we're going to take 10 mLs of calcium chloride. We're going to measure it in a graduated cylinder. 10 mLs, and then we're going to put it in the vial. So now we have 2 vials with this stuff. 2 vials, right? One with 10 mLs of sodium carbonate, and another one with 10 milliliters of calcium chloride. And we're going to take those and add it to a dry, because we don't want any extra mass, a dry flask. Okay, that's this mother. Right? We're going to take all these things and we're going to put all this stuff, the 2 vials, and we're going to get their mass. Put all this, get the mass of these 3 things, three things on the analytic balance. Okay, and all this is going to be our mass before, right? Because nothing's happening. Okay? And we want to see if the mass before equals the mass after. I mean, that's the whole idea. Okay, so on our analytic balance, we've got this little vial, and the empty flask. Okay, and then we're going to get the mass. Okay, that's number 1. Okay, now the second thing we're going to do is now pour from that little vial the calcium chloride, CaCl2. Remember, that's 10 milliliters into the flask. Okay. And we're going to put in the sodium carbonate also. Okay, and we got this stuff together, and we're going to swirl it together. And record this. Record what you see. In other words, if you see bubbles, if you see any white particles, if you see any, I'll just say particles forming. The particles that form are called the precipitate. Okay. If there's any heat, if you feel any heat, etc. Okay. All right. Now the third thing we do. Now place the 2 vials, the 2 empty vials, right? Now place the 2 empty vials and the flask on the analytic balance. Okay, and record the mass. Record the mass. Okay, so we've got, there's a vial, is the vial. Now we've got the flask with the calcium calcium chloride and the sodium carbonate stuff in there. And this is all on the balance. And then we record the mass. Okay. Now 4. Okay. And again, you should see probably the mass is less. Why? Well, you'll see bubbles, and those bubbles are going to be carbon dioxide escaping. Okay, the carbon dioxide is escaping. All right, and I'll write the reactions when we're done. Okay, so now the next thing is now use a dropper. Oopsie, now use a dropper. Okay. And you know what a dropper is, that's that little thing there. Okay, and we're going to add the sulfuric acid. Aqueous. Okay, aqueous, that's the sulfuric acid. Okay, and the procedure says add it drop by drop, add drop by drop. Okay, remember, it's on the balance. All this is still on the balance, on the analytic balance. So we're going to add it drop by drop to the flask and swirl it. Gently swirl it so it mixes well. Okay. And we're going to weigh, and we're going to check the mass, and they tell us every 30 seconds or so. Every 30 seconds. Okay. Until, and you'll see the mass change until 2 successive, that means one right after another, 2 successive weighings differ by less than a hundredth of a gram, less than 0.010 grams. Okay, that means it's stabilizing. And it's not losing any more, very much more carbon dioxide. Okay. So let's look, let's go through some of these reactions. Okay. So we've got the calcium chloride, aqueous, there's the aqueous, right? And we're mixing it in the flask with the sodium carbonate, aqueous, okay? And we get this CaCO3, S. S means this is solid. So that's going to be the little particles that you see as calcium carbonate. This is calcium carbonate. Calcium. CO3 is carbonate. plus salt water. 2 NaCl is table salt, and it's aqueous, so that's just salt water. Okay? Aqueous, salt water, salt water. Okay? And then when we now add the sulfuric acid, now add sulfuric acid. Remember the sulfuric acid is H2SO4. Again, that's aqueous. I don't want to forget the aqueous. Okay, so we're going to add, that reacts with the calcium carbonate, CaCO3. That's the solid precipitate, plus the sulfuric acid, H2SO4 aqueous. And here is where we get, and again, well, we'll see, CaSO4, and that's a solid, okay, plus H2O, that's a liquid, that's water, plus CO2, and that's a gas, and sometimes you'll see an arrow because this is carbon dioxide that escapes. So that's why the mass is different. Carbon dioxide escapes. Those are the bubbles. Okay, those are the bubbles you saw. Okay. So that's the reaction. And you need to know these reactions. Okay. And then you record the mass and you see the mass is slightly less, hopefully. And the mass that's missing, there's no missing mass. There's no missing mass. It has to be accounted for, right? So the mass you start with should be equal to the mass you finish with. And it is, if you take into account the escaped carbon dioxide. Okay, that's that experiment. Have fun. Good luck. And don't forget, you really need to know these reactions. The calcium chloride plus the sodium carbonate gives you calcium carbonate and salt water. And then with the sulfuric acid reacting with the calcium carbonate gives you calcium sulfate, water, and the escaped carbon dioxide. You should know these reactions. Okie doke. Good luck.